Alright guys, here we go. We're going to do 16 through probably 20 on this run right here. So, which statement about kx equals negative x squared minus 2x plus 15 is true? Okay, so we're looking here at these. Notice over here on the right hand side, all of these are factors. Okay, so that could help us out here. But then notice here they also give us the zero. So there's multiple ways to do this type of problem here. So the way I would suggest you do it, you could go back and factor. Now, what kind of gets weird is the negative out in front of the x squared. We need to technically factor that out or undistribute the negative first before we're going to factor the problem. But I'm going to show you a little bit easier way, in my opinion. So what I'm going to do here is I'm going to go and type this equation into the graphing calculator. So I'm going to close out this real quick, pull up my graphing calculator. And I'm going to start typing this in. It's negative x squared minus 2x and then plus 15. Hopefully this works. Okay, yeah, it's covered up. Plus 15. And I'm going to look at the x-intercepts of the graph. Because another name for zeros, that's basically your x-intercepts of your graph here. And notice here on the graph, I'm not sure, yeah, you can see my mouth. The graphs, the x-intercepts are the zeros here. You got one at positive 3, and then one of them over here at negative 5. So those hopefully can get my answer right here. What do we say? Negative 5 and positive 3. So that looks like it's going to be answer G right there. Now I want to also show you factoring here real quick. So if you have negative x squared minus 2x and then plus 15. When I was saying earlier undistribute a negative, that means basically divide everything by a negative, or kind of like a negative 1, I guess. So if you undistribute a negative here, that's going to make your first thing an x squared, just a regular x squared. It's going to make a positive 2x. It's going to make a negative 15. Then we got to ask ourselves, okay, what times what gets you negative 15? Then it's got to add up to this thing here in the middle. So you could say x, you can go plus 5 and then x minus 3 with the negative outside. So that'd be how that equation factors, and notice that does match up with our G graph. So definitely G. That's two different ways you can think about that question there. So okay, 17. This one, there's a couple different ways you can do this problem. The exponential function model below represents the number of square kilometers of land occupied by cane toads. Okay, that's interesting. X years after the animal was first introduced into Australia. Based on the data, which measurement is closest to the number of square kilometers of land that will be occupied by cane toads for 40 years after this animal was first introduced into Australia? Okay, so we'll look kind of what's going on here with this one. So they didn't actually give us the 40th year, so we're going to have to kind of sketch or maybe guesstimate where we think that might be. So if I kind of continue kind of like a slight curve going on here, I'm thinking it's going to be maybe around 800, maybe even 900 here. So maybe one of those options will be there. And obviously you see the 800 right here. Now let's talk about why it couldn't be some of the other ones. First of all, you got 55 or 550. So that would be roughly right here on the graph right there. Obviously, you know, your graph's not going to just level off right there, just stop growing. So it can't be that for sure. Let's talk about the 600,000. Same argument here. So just barely higher than that. Definitely not going to work for 600,000. Now the 1.25 million, that's going to be way up here. 1.25. Wait, was it 25? Yeah. So that's going to be way up here. So you're saying this thing is going to just all of a sudden shoot up like that, and maybe the curve can kind of change like that, but I really doubt it. I don't think it's going to have that strong of a change right there. And if also you can kind of look here at your table towards the bottom here, notice like from here to here, you're growing by about 100,000, maybe a hair less than 100,000, or not 100,000. Yes, 100,000. I'm sorry. From the 25 or to 250 to the 367 right there, it's growing about, a little bit more than 100. So this one's a little bit less than 100 from here to here, a little bit more, just a hair more. That's like almost 200,000. So I don't think it's going to jump from, 539,000 to 1.2 million. That's kind of a drastic jump right there. So I think D is going to be the best option. Now, if you want to, you could probably go into your graphing calculator and use your regression to get a line of best fit and use your exponential model. And then that would be in this format. I'm not exactly sure what it would look like exactly, but it'd be in this format. It'd be y equals ax plus b, some type of starting value. It looks like it probably starts at 3,600. So it'll be like 3,600. You'll have some random b value. But if you get that equation, you could just plug in 40 in for your x to get an exact amount, or not really an exact, but maybe more of an estimation of what that should be to get a closer answer there. But I would just use logic there. 1.25 is way too high, and then the 550 and the 600, those are a little too low. So D is probably your best option on that one. Okay, which of the following is equivalent to this equation? 3x minus 4y equals 6. Notice that all of these here are solve for y. So essentially what they're trying to ask us to do is solve for y. Alright, and when you're solving for y on linear equations, basically getting in y equals mx plus b or slope-intercept form. So I'm going to do that by subtracting 3x from both sides. That's a negative 4y left over on the left-hand side because these cancel out. Negative 3x and 6, those are not like terms, so you can't combine them. Just, write them together. Then divide by negative 4, divide by negative 4, divide by negative 4. So you got positive 3 over 4x, and then minus 3 over 2. So let's see, what do we got here? Looking like J for that answer. There we go. Pretty easy one there. Nothing too wild. Little trick here, if you had the Desmos app during the test, you could go ahead and type in both equations into Desmos and then just see which ones overlap, or which ones are technically then the same. So that's one way you could do it as well. Alright, the table represents some points on the graph of a linear function. What is a rate of change? Okay, and I think they've already asked the question that we've gone through. Rate of change, once again, if you didn't see those videos, rate of change is slope. Slope, you can use your slope formula, y2 minus y1 over x2 minus x1. They do give you that formula on the STAAR exam. So I just choose, some of the nicer points here. I would not use these 0.5 points down here. Those will kind of get a little bit messier here. So I'm going to go ahead and use these 2 points here. So I'm going to go 3 minus 12. All right, and then I got to go in that same order, 0 minus negative 2. Which, don't forget, minus and negative changes as a positive. This is negative 9 over 2. Once you simplify, easy breezy problem right there. So there you go. I guess we're going to do one more here for this video. So rate of change, aka slope. Hopefully not too bad there. Okay. Now this one here, they did not give us a whole lot of room to work this, but okay. So a manager pulled a total of 21 coffee mugs and keychain, or purchase. I'm sorry. Manager purchased a total of 21 coffee mugs and keychains. Okay, so I guess he's buying a little bit of both there, and he bought 21 items. Each coffee mug cost $8.50, and each keychain cost $2.65. The manager spent a total of $132.50. How many of the coffee mugs did the manager purchase? Okay, so really right here, you actually have two unknown things. So I'm going to write my two unknown things. You have mugs, and then you'll have the keychains. So I'm going to use, N for the number of mugs, and K for the number of keychains. Okay. Now, the first thing, they give us a total of 21 items bought. So I'm going to say 21 equals, and then we're just going to say, I guess, n plus k. All right. Now the second equation here, it's going to be dealing with this $32 or $132.50. So that's a total. Usually when you have a total, that usually means you're adding things. Now I can't just say it's the number of mugs plus a number of keychains, because there's some that, you know, the $132, that's dealing with money there. So I need to attach some type of money value to the mug. So I'm going to say $8.50 per coffee mug. And then what was it, like $2.75 for the keychains. Okay. Now the way I would do this, especially if you have Desmos, and I'm going to pull that app up. I'm going to type that into the Desmos, and you should be using test mode, I guess. I'm going to clear out what I got here. I would use Desmos and type that equation in to solve it. Alright. You can solve when you have two solutions. Sorry, I'm trying to find the equations. Okay. You can solve systems of equations by substitution, elimination, or graphing. But the reason I like graphing with Desmos is because you don't have to do any solving for y or x. Just type in your two equations. So I'm gonna assume the mugs. We'll say the mugs are x, and then I guess the keychains will be y. So I'm just typing in these same equations that we had. So was it like 850? I think x, and then plus 275y. I'm going to look there at that intersection point. The nice thing, you don't have to do any fancy things. You just type those in, click on the intersection, and then you get your solution there. So apparently that is 13. I think we said x is the mug, so 13 mugs and 8 keychains. So let's go back and fill that in. And what were they asking for? How many coffee mugs? So that'd be 13 of them. So that's one way to do it. I'm going to show you here an algebraic way. I'm going to solve by using substitution. So what I want to do here, I'm going to solve this by substitution. This is just an algebraic way to do this without Desmos, I guess. So what I'm going to do here, I'm going to cancel out my k's eventually. So I'm going to go ahead and solve this equation here for k. So I got 21 equals m plus k. And I want to subtract m from both sides. So we're going to go 21 minus m equals k. So what we're going to do is we're going to take that and we're going to substitute it or plug it in for the k right there. I'm going to rewrite all this here. So 132.5 equals 8.5 m, and then plus 2.75, and then parentheses 21 minus m. Okay, so we'll start to clean this up. We're going to go do some distributive property here. 8.5 m, we're going to go 2.75 times 21. That gets us 57.75. So eventually we will subtract that. Oh, whoops, 75. And then minus 2.75 m. Don't forget that negative right there, because I've done that in the past. I'm solving these on accident here. So what do we got? Combine like terms. So we'll go 850 minus 2.75. And that gives you 5.75 plus 57.75. Oops, forgetting my 7. And then 132.5. So then we will subtract. So I'm going to go 132.5 minus the 57.75. And that'll be 74.75. And then equals, oh, I'm forgetting an m somewhere. Oh, here it is. My bad. 5.75 m. So then we'll go divide by 5.75. Oh, and good. That comes out to m equals 13. Now, if you wanted to algebraically go figure out the number of keychains, you could go plug it back into one of your original equations. And so you could plug in 13 there, subtract over 13, and then you get something like 8. So that's a different way to do that same type of problem. Alright, that is it for these problems.